That's why I love you guys so much, because you come up with stuff that I did not do, so I can show it in class. That's awesome. Okay, so this is a rational function. I did not show how to find the inverse of a rational function. I only showed the linear function. Perfect. So we know that in order to find the inverse function, or let's review this. Will this function have an inverse? Only if that's true, there's a domain, correct, perfect. But a function has an inverse function only if
there's only one, like x and y.
If for each y there is also only one x.
Yeah.
How is that called? Thank you. So this function will have an inverse only if it is 1 to 1. But I'm pretty sure that the problem says, here is a 1 to 1 function, find its inverse. But I just want you to remember, not all functions are 1 to 1. What function is this?
Absolute value.
Is this 1 to 1? No. But this rational function is 1 to 1. Just remember, only 1 to 1 functions have inverse functions. Awesome. Good. So we know that there is a 4-step procedure to find the inverse for this function. Perfect. What is the first step? First, I replace f of x by y. X plus 8 over x minus 2. In step 2, I interchange, and I know exactly why I'm allowed to do that, right? Why am I allowed to? I never do that, right? But why am I allowed in this case to interchange x with y?
Because there's only one.
Because the y value for f of x becomes the x value for
The inverse.
f inverse. That's the reason why I'm allowed to do this. Perfect. In step 3, and once I'm going to give you a little hint, you will know how to solve this. Here's my hint. That's my hint in blue. What is that? What am I saying to you? Exactly. It's a proportion. So, the left-hand side, what would you write to write? Y plus 8 is the left-hand side. And then you either write it like this, or you distribute at once. That's fine. Both are okay. So y plus 8 equals xy minus 2x. The variable is? What are we solving for?
Y.
Exactly. So what do I have to do next? I'm focusing on y. So I have to move this here and this here. But the focus is y. My first concern is y. It's correct to move a to the other side, absolutely. But my focus is y. So then I have y minus xy equals negative 2x minus 8. And now what?
It's like you just take out the y.
Exactly, because they are not like terms. My only chance is to factor out y. Indeed. What is left in parentheses and how many terms? Just to make sure that we don't make an error here. How many terms inside? Exactly, because that's how I started with. I started with 2. I have to have 2. So what is left in parentheses then? Awesome, thank you. So then y equals?
Would you divide?
Of course, by whatever multiplies y. Exactly. Oops, I meant to write x, of course. I'm gonna, what will I do without whiteout? I guess this is my best friend. Of course, 1 minus x. And step 4, what do I do?
Oh, because y is up above.
That's it, F inverse. So I could factor out -1 at the top and factor out the -1 at the bottom. So that would be the nicest thing to do, like this. Remember, descending order, I keep saying that all the time, -x plus 1 minus minus. This is the nicest form.
So if you factor out the negatives and you don't have to put them in the inverse?
Because I factor out from the top,
Yeah.
and I factor out from the denominator. When I divide a negative by a negative, I get a positive. I would not eliminate anything. But it turns out that negative over negative is positive, so that's why it went away. Otherwise, no. Jeremy? Just for you. Is this okay? Do we remember this from chapter 2? How to solve rational equations?
Yeah, but then like it asks you to verify that your equation is correct.
Good. Okay, so we'll verify it right now.
Can we do it?
Yes, of course. I'll do one and you'll do the other, okay? Which one would you like us to do? The F comp F inverse or the F inverse comp F? They're the same. It doesn't matter. I still have to put a rational function inside another rational function. It doesn't matter. You choose. Or anyone else who wants to choose. Do we want F comp F inverse or F inverse comp F? That's fine. That's fine. Other questions from me before we do that?
So you flip oh, never mind. You just took away the negative, so you had to flip the bottom.
I always have to present everything in descending order. So when I present -x plus 1, it has a negative leading coefficient, as we did in factoring. So I factor out -1. So -1 times x is -x, -1 times -1 is +1. And it turns out that it gave us an easier expression to work with. Instead of having 3 negatives, I only have 1. Better? Everyone? Okay? Okay, so we want to show that F inverse, I didn't mean that, F inverse comp F of x is, what do we want to show? That this equals anyone other than Deborah and Paige? We want to show that this equals what? Anyone else?
It would be 2x plus.
What do we want to show?
You have to replace
At the end of the day, what do we want to show?
f of x.
We want to show that this equals? Let's go back. I give you $10 and then I take it back. What happens to your
You want
portfolio?
to equal x, right?
Excellent. This is my target, to show that this equals x. I cannot force it, right? I cannot fabricate it. It has to be there. Otherwise, this is wrong. Awesome. Very good. Thank you. So then I start with f inverse of f of x. Correct? So far? Okay. Then this is f inverse of, I go back to the function, x plus 8 over x minus 2. And of course, I have to write x not equal 2. And here, of course, I have to write for the domain to be clear, not equal 1. But that will not come into account right now. Okay, so I put in x plus 8 over x minus 2. So now I go back to f inverse. Look at what f inverse says. F inverse says 2. 2 times whatever you want, whatever you have in here, plus 8 over whatever you have in here, minus 1. So, please dictate, anyone. Yes? Yes. Awesome. Plus? Awesome. The denominator, great job.
Wait, how did you do that? Oh, wait, no. Let's go with this. And then
Good.
The denominator is x plus 8
Yes?
over x minus 2 minus 2. Oh, minus 1.
Good. Is this clear, everyone? Amanda?
Yeah, we just put that in for x.
Exactly. That's how I check. Here's why. Look here for a second. F inverse of this. So this becomes my x. And this is the x everywhere in F inverse. Is this okay? Everyone, is that a yes or a no? Yes? This is the same expression. So the same expression is here in the denominator. Minus 1. Is that okay? Everyone? Okay, so now this is a complex rational expression. We have to find the least common denominator, top and bottom. Remember again, we cannot fabricate it, but what is the target one more time? Exactly, that's the target. Awesome. So what is the least common denominator at the top? There is only one. Yeah, there is only one. Good. So then if this is over 1, what do I have to multiply the top by? That's why I was saying you will feel tremendously better if you would find the time every weekend to redo the test with solutions. You will always have everything that we studied fresh in your mind, and it will really help. So please take the advice of an older person. Okay, so what do I have here? Good. So remember, this has to be distributed. It's at the top. It's 2 over 1. We have to distribute it, and then add 8 to x minus 2. So what do we have? Awesome. Plus? Very good. Awesome. The denominator. Obviously, it's the same denominator, so what do you multiply negative 1 by? Very good. So what do we have? Perfect. Good. Clear, everyone? Okay, so now we do what? Perfect. These two go away. What is left at the top? Over 10x over x minus 2 times.
How did you simplify that?
16 minus 16, I give you $16 and take it back.
Yeah, and then it was 2x plus 8x.
2 apples plus 8 apples, we still have 10.
Oh, we're creating a new equation.
Better? Okay, now the denominator. These two go away. How much is 8 plus 2?
10.
So I flip this into x minus 2 over 10 because I divide two fractions. The top fraction is 10x over x minus 2. The bottom fraction is 10 over x minus 2. So I have to flip the bottom one. Are you with me? Any questions? Okay, what next? We simplify. We do not multiply. Please do not multiply before you simplify. And cross multiplication rule is in a proportion. So I know what you mean, but there must be a different terminology. Okay, so then the answer is it exactly what we expected? What does that mean? What does that say? And I still have to show the other one. But what does they say about 2x plus 8 over x minus 1? It is the inverse of which function? Awesome. Amanda, okay? Yes? Good. Other questions for me? Anyone? Anything? Anything else? Anything else? Anything else? Okay, 3.2. Polynomial functions. Can anyone give us the simplest possible polynomial function of odd degree? What would that be?
X cubed.
Odd degree, the simplest possible. You're so far x. X is the simplest possible odd degree function. Degree is 1. What are the options for any linear function? 1, which is a positive slope, coming from what type of values? And going to? Good. And what is the second option? Negative slope, coming from, good. All odd degree functions will follow the same procedure. So if it's this case, with a leading coefficient that is positive, they will come from negative and go to positive. And if the leading coefficient is negative, they will come from positive and go to negative. All of them. Any odd degree. 3, 5, 7, 9, whatever degree you think of. If it's odd, it will follow this. What do I mean by that? It will be called end behavior. Okay? That's the end behavior. What it does in the middle is a totally different story. I'm only talking about the end behavior here. What about even degree? Can you give me the simplest possible even degree function that you can think of? Right. So what are the options for x squared? This with a, what type of leading coefficient? Positive, right? And this, negative. That's it. All the even degree functions will follow the exact same pattern. So it's either this, from infinity to infinity, with a positive leading coefficient, or this, negative infinity to negative infinity with a negative leading coefficient. So please keep that in mind. This is one prep before we start graphing polynomial functions and understanding them. The first prep. Where do they come from? Okay. Second prep is multiplicities of the x-intercepts. Never heard of it? What does it mean? We never discussed this because we never got to higher degree polynomial functions before. Although I did mention something, you may remember. But I didn't use the name of multiplicity. Okay. Let's talk about what is called odd multiplicity. And then even multiplicity. Odd multiplicity, even multiplicity. Okay, so let's take a look at the following equation. X to the third equals 0. It is a polynomial equation. The degree of the polynomial is, how many solutions do we have to write? Good. So please give me 3 solutions. Of course, of course. That means that the solution x equals 0 appears how many times in this equation as a solution? We call that multiplicity 3. That's all it is. What about x squared equals 0? What type of polynomial equation is this? You will say polynomial or quadratic in this case. And I will ask you how many solutions will you give? 2. And I will say x equals 0. What is the multiplicity then? That's it. That's all it means. But now, how does this reflect in a graph? That's the key. Okay. Any odd multiplicity will cross the x-axis, meaning because it's an odd number of times x equals 0 appears as a 0 of the function will cross at 0. When there is only one solution, it will cross straight, fast if you want. But if there are 3 solutions, x equals 0, or x equals 5 or 10, doesn't matter, it will do this. It will still cross only once, but it will not cross like this. It will take its time. It will approach slowly and move away from the intercept slowly. So this is multiplicity 1, this is multiplicity 3. Let's look at multiplicity 5. It's even slower. So every odd multiplicity will be a cross of the x-axis, but it depends how. Fast if it's 1, slow if it's 3, very slow if it's 5, and beyond that, very, very slow. What do you think about even multiplicity? And we had an example with even multiplicity. X squared, right? So for an even multiplicity, that is a term. Always a term for an even multiplicity. It turns there. It has a max or a min. It can do this or it can do this. So this is multiplicity 2, multiplicity 2. How will multiplicity 4 look like? Here it is, an example of multiplicity 4. It takes its time till it touches the x-axis and moves away from the x-axis slowly. That's all the prep we needed, and now we're ready to start. Would you like to start with an odd degree or an even degree? Once we understand one even degree, we'll graph everything. Once we understand one odd degree, we'll do it. And it doesn't matter anymore. So which one do we want to start with? Odd or even? Very good. So we want to start with an odd degree. Do I get to choose? Or you want to choose? Okay, thank you for your vote of confidence. I will choose. And it will be 53. On page 378. And the function is f of x equals 3x squared minus x cubed. Like everything new, the first problem will take 10 minutes, as you know, and the subsequent ones will take 2. So bear with me. I highly recommend this table in which we will summarize all our findings. And the sequence of steps, I can go back for a second. The sequence of steps are here. Domain. They don't have to be in this order. Doesn't matter, the order is not important. Domain and behavior, which we just talked about, degree, maximum number of turns, max min with the graphing calculator, x-intercepts, multiplicity of the x-intercepts, symmetry if it's odd or even, and table of ordered pairs and the range. So this is the whole thing, a mouthful. However, if you agree to use this table, all the information will be summarized in here, and you will have a basis of graphing. For graphing another function, it would be so easy, I think. Okay, so first the domain. This is a polynomial function, and of course, let's do a little bit of work here before we start. What do you think I'm going to do right away? Yes, but first arrange it in descending order. That's the key. Always remember, for everything, factoring, whatever you want to do, it has to be arranged in descending order first. And yes, then I will take out what? Yes, with a negative, because I don't want a negative leading coefficient in there. And in parentheses, we have, careful, one more time.
X minus 3.
Perfect. Indeed, so x minus 3. Good. So domain. Once we finish filling up the table, we're done. We are ready to graph. Domain, please. Right, very good. Thank you, Andy. It's a polynomial function defined everywhere. No restrictions, no problems. Good. Degree. Very good. Maximum possible number of turns. Degree minus 1. So always the maximum possible number of turns is degree minus 1. It doesn't have to turn that many times. It cannot turn more than that.
So that's only for I, right?
For everything.
Okay.
So what about x squared? What is the degree of x squared? What is the maximum possible number of turns? Exactly. So this is 3 minus 1, which is 2. The maximum possible number of turns for any polynomial function is the degree minus 1. What do we mean by turns? Max min. That's what we mean. Good. 2. Very good. So how many solutions will you write for the x-intercept? Careful. Exactly 3. The degree is the degree, and that tells us how many solutions we have to write. Good. How do I determine the x-intercepts? Awesome. So then I have negative x squared, x minus 3 equals 0. Of course, I will multiply both sides by negative 1. I don't like a negative leading coefficient when I solve an equation. And again, how many solutions do I have to present? Good. 2 of them are? Very good. And the other one is? Good. What is the multiplicity of 0? 2. What is the multiplicity for x equals 3? I go back to the table and I put 0, 0. And what does a multiplicity that is even, what does an even multiplicity do? X times x. I have 2 solutions, 0, right? This is what we just did here, x squared equals 0. These are 2 solutions, x equals 0. X equals 0, x equals 0, x minus 3 equals 0. Is that okay? So multiplicity 2. So what does multiplicity 2 do? Is it a cross or a turn? That's my question. A turn. So I make myself a note. Turn. 3 comma 0 is a cross. A regular cross. Okay, now I would like to determine the end behavior. This function, it has degree odd or even? Odd. So it must behave exactly like the linear function, either with a positive slope from negative infinity to positive infinity, or with negative slope from positive to negative. What is the leading coefficient of this function? Perfect. So then the end behavior, will it be this way or this way? This, exactly. So from positive to negative infinity. So from positive infinity to negative infinity. Ready? Okay, so let's see what this tells me. Just follow my hand if you could. It says it comes from positive infinity. It comes to the origin, but it turns there. So it has to come up to another maximum somehow, and then turn and cross at 3, 0 and go to negative infinity. That's it. So one more time. The table says from positive infinity, it's coming to the origin, but it turns there. That's my note. It turns. It has to come to a maximum because it has to come back and cross at 3, 0 and go to negative infinity. That's the end of it. That's all we have to do.
How do you graph that if you don't have the math?
In a minute. So one more time. This is one point. This is the other. I didn't say anything about the y-intercept because when x is 0, y is 0. It's coming from positive infinity. It turns at the origin. Comes up to a maximum. We have no idea how high. It comes down to cross at 3, 0 and go into negative infinity. And this is the graph of f of x, negative x cubed plus 3x squared. If you remember, one of the lists of the items on the list was max min with a TI. So we cannot in this class determine the local maximum. So There must be something going on here between 0 and 3, and this is it. So this is a local max. We cannot determine in algebra, or just with algebra, we cannot determine that point. So we need a graphing calculator, so let's do that. So please put the function in the graphing calculator. If you need mine, if anyone needs mine, it's right here. In y equals, please put in negative x cubed plus 3x squared. In y equals negative x cubed plus 3x squared. There is no vertex, no other function but quadratic function has a vertex. So do not mention any vertex about anything, anywhere, anytime, unless it's quadratic. Second thing is, I want to adjust the viewing window. I already graphed the function, and I know that I really don't need too much to the left-hand side, maybe -4. I don't really need too much to the right-hand side, maybe +6. And I don't need too much under the y-axis, under the x-axis, because it doesn't have any action really under. But I don't know how high that goes. So with a window, I'm going to say -5 to 6, maybe with a scale of 1. Y minimum, -4 is good enough. And y maximum, maybe 8. I'll see in a minute in order to see the better graphs. So it's coming from -infinity. It's very clear that it turns at 0, 0. It comes to a maximum. It has to turn. These are the maximum 2 turns that the function can have. And then it crosses it through 0, going to -infinity. In order to determine this maximum, I will tell the calculator to look for the maximum between 0 and 3. So we go to second and calc. I will have to choose number 4, which is maximum. I will have to give it between 0 and 3. So 0, left bound, 3, right bound. I don't want to guess, just give me the maximum. And it turns out that the maximum is, what roughly is 2. When x is 2, y is 4. Any questions?
Where did you say your window to?
The window is right here.
Yeah, what did you say?
Oh, I said it to, I just wanted to, because I already,
Yeah, just my calculator windows is messed up.
I already graphed the function, so I just wanted to have a better picture in the viewing window. But you don't have to always adjust the viewing window. I would like to do that. So I go back to, we will have many more examples. I'll go back to my table. I will put 2, 4. I will say that this is the local maximum 2, 4. I will determine the range, -infinity to infinity. Obviously, the function is not symmetric. I can say f of -x does not equal f of x, and f of -x does not equal -f of x, as we know, meaning not even and not odd. And I exhausted everything. Once I create this table and I have all the information in the table, and on the side, the degree and the number of turns, and the range and symmetry, I'm done. The graph should not take more than 3 minutes at the most. Any questions? Of course. We just started. Yes, please choose. You want an even, odd? We did an odd, so maybe we should do an even. Do I get to choose?
No.
Okay. Thank you. 58. F of x equals x to the third, x plus 2 squared, and x plus 1. Again, feel free to choose the next one after this. Okay. This one is nice because it's already factored for us. Great. Okay, degree, please. Or domain. Yes, degree is 3, 2 plus 1. X squared, x cubed, and x. Degree is 6. Awesome. Maximum possible number of turns. 5 max possible number of turns. It does not have to turn 5 times, but it cannot turn more than 5 times. That's all we are saying. Now you remember x cubed. This is x cubed, right? This is the graph of x cubed. What is the degree of x cubed? What is the degree of x cubed? Just x cubed. 3. How many turns can it have maximum? How many turns does it have? None. It doesn't turn. Look at x cubed. Although it can turn twice, it doesn't turn at all. It has no max, no min. It's always increasing. So it doesn't have to turn 5 times, but it cannot turn more than 5 times. Very good. Domain, please. Very good. Now let's think. Since the degree is 6, the end behavior will be similar to the behavior of which simple function we know? Quadratic. Is it this with a positive leading coefficient, or is it this with a negative leading coefficient? Positive. It's very clear. X is positive, x is positive, x is positive. All coefficients, leading coefficients are 1. So then, if it's positive, this is the end behavior. Positive infinity, back to positive infinity. Good. How many solutions will you give for the equation y equals 0 for the x-intercepts? 6 solutions. Perfect. So we have x cubed, x plus 2 squared, x plus 1 equals 0. So I need 6 solutions.
3 of them are 0.
Awesome.
2 of them are -2, and 1 of them is -1.
Very good. Perfect. What is the multiplicity of solution 0? What does the function do over there? Cross or turn? Cross. All odd multiplicities are cross. Always remember the linear function, right? So what type of cross? Straight, fast, or slow? Remember x cubed. Slow. X equals -2. What is the multiplicity of -2? 2. What does the function do there? Turns. Fast or slow? Yes, it's the first type. Good. X equals -1. What is the multiplicity of x equals -1? 1. What does the function do there? Very good. Now we have to add up the multiplicities, and what do I have to get?
6.
Exactly, the degree, of course. 3 plus 2 plus 1, do I have 6?
Yeah.
Perfect. So let's put them in the table now. Add 0 is 0. Add -2 is 0. Add -1 is 0. There is no point in discussing the y-intercept because it's already in there. I write in the table exactly what is happening. -2 is a turn. -1 is a cross. And 0, 0 is a slow cross. Let's see what we come up with. Ready? That's all I care about. Obviously, it's not symmetric, and we'll determine the range. And max min with the graphing calculator, this is it. You can find millions of points if you want to. There is no need. Okay, ready to graph? Okay, so let's make sense of the information first. Let's think about it, and then we'll look at it and graph the function. It's coming from positive infinity. It will turn at -2, 0, comes up to a maximum. It will cross at -1, 0, come back, it has to turn because it will cross again at 0, 0, very slowly and go up. One more time. Coming from positive infinity, it will cross at negative 2, 0. It has to turn, oh, I'm sorry, it turns at negative 2, 0, has to come up to a maximum. It crosses at negative 1, 0. It has to turn again. It comes to the origin, but takes its time to cross at 0, 0, and then go to infinity. Just graphing it with a graphing calculator doesn't mean anything. Understanding it is important. Okay, so I have to plot the points. I'm going to use a wider unit. So this is negative 2, this is negative 1, and this is 0. The table says it's coming from positive infinity and turning at this point. Fine. But it has to cross here, so obviously it goes to a maximum and then crosses. There is no other way. So there must be something in here. It's crossing a negative 1, 0, but it has to turn because it has to cross again here. So it has to come to a minimum and then slowly cross at 0, 0, slowly, and go into infinity. The analysis of the graph is more important than just getting the graph perfectly fine and using the calculator. So, of course, I don't know how high this is, have no idea. I don't know how low this is, but that's all I can do in algebra. If you take my calculus class, we will determine those max and mins with no calculator. It will be fun. Okay, so now we can put in the graphing calculator, not before I write f of x equals x to the third and x plus 2 squared and x plus 1, and this is x, the origin, and y. And now we are checking our understanding. So in y equals, erase what we had, and we have now x to the third. And in parentheses, we had x plus 2 squared. Oops. X plus 2 squared. And then x plus 1. Okay? Very good. So now let's think about the viewing window. So pretty much the same viewing window I'm happy with for now, what I had before. So let's hit graph. It's coming from positive infinity. It has to turn here. It has to come to a maximum because it crosses at negative 1, 0. It has to come to a minimum. It has to slowly see the difference between this cross and this cross. Look how straight this is and fast, and this is how slow it is. See the difference? Okay, now I want to zoom in because I like to see that area much better. And I'm going to change just the y's from negative 1 to 4 and see what happens. It's coming, turning, much better. See, one more time the difference between multiplicity 1 and multiplicity 3. I want to determine this maximum. I will tell the calculator to find it between negative 2 and 1, and between, for the minimum, between negative 1 and 0. Yes, ladies, any questions? Any questions? I only changed the y coordinates into, the y minimum to negative 1 and the y maximum to 4. Only because I wanted to see a better graph. So now I'm going to go to second and calc. I want to determine a maximum, which is 4. And I want the maximum between negative 3 and negative 2. So, no, between negative 2 and negative 1, sorry. So I want negative 2, enter, negative 1, enter, and I don't want to guess. Just give me that maximum. Is at negative 1.5, and the maximum is a tiny maximum, 0.42. I put it in my chart, negative 1.5 and 0.42. So negative 1.5, 0.42. You do not have to go back and adjust your graph. at all. I'm not going to adjust my graph. So now I'm going to determine this minimum, which I will tell the calculator to find it between -1 and 0. So with second and calc, between -1, oh, of course, sorry, minimum, which is 3, between -1, enter, and 0, enter. And I don't want to guess, just give me the minimum. And the minimum is when x is -0.67, and the actual minimum is -0.18, a tiny minimum. So -0.67 and -0.18. Yes, any questions? Any questions? Is this okay?
Are you gonna get this?
I'm sorry?
And then
You will be asked to find the minimum and the maximum.
even if we're calculator inept.
Person?
Yes.
Yes.
Yeah. Maybe.
I have a
meeting after this and I can spend time. No, I told.
Okay.
I was trying to figure out.
I was trying to get
Any questions? Any questions, ladies and gentlemen? Any questions? Any questions? Would you like to continue with another even degree, odd degree? What would you prefer? Let me ask you this. Let me ask you this word problem first. Because I'm sure you are asking yourselves, when do we need this, or why do you need this? Let's see. Let's take a look at a word problem. Yes.
So like, does it really matter if it's even or odd?
Yes.
You still approach it the same way, don't you?
Correct. Here's the only difference.
Okay.
There's nothing else.
Were you a cheerleader?
If it's yes, I'm a cheater. Just for you. So if it's an even degree, if it's an odd degree,
It's a robot.
that's it. The rest doesn't matter.
And you know if it's even or odd if you add up the degrees and they're even or odd?
Yeah.
Okay.
Yes, if it's a factored in a factored form, you're really adding, but you have to multiply and see what it is. Yeah, but you're adding the powers, because ladies, please. So when you multiply x to the third by x to the fifth, you copy the base and add the exponents. Correct.
So that would be even.
Whatever you get. Yeah. Oh, yes. Or what did I say? Yes, it will be degree 8. Yes. Yes. So based on the leading coefficient, it will be this or this. That's the only difference. Very good remark. Thank you. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack, and we are talking about 0 to 12 minutes. So on the x-axis minutes, on the y-axis the heart rate. Part A. For which time periods during the diagnostic evaluation was the woman's heart rate increasing? We know this from chapter 2. Increasing.
1 to 4.
1 through 4, yes. Between 1 and 4, and 8 to 10. Do you agree? Perfect. Decreasing.
4 to 8.
4 to 8, 10 to 12. How many turning points? We know that. Let's read it, but we know what it means. From increasing to decreasing, or from decreasing to increasing.
4. Well, be 3.
Yes. So increasing, decreasing, that's 1. Decreasing, increasing, that's the second one. Increasing, decreasing, that's the third one. So 3 turning points. Suppose that a polynomial function is used to model the data. Use the number of turning points to determine the degree of the polynomial function of best fit. The degree.
If there's 3 turns, there's 4 degrees.
Exactly. If there are 3 turns, the degree must be 4, at least, minimum. Okay. Is that clear?
Yeah, because you had to add 1. Right?
Yes. Because if it's degree 4, the number of turns is 3. 4 minus 1, correct?
To get turns.
Is that okay, everyone? Yes? Okay. For the model in part D, yes, any questions? Jeremy, go ahead. For the model in part D, should the leading coefficient of the polynomial function be positive or negative? It's degree 4. We established that. Should it, if it's positive, it has to do this. Right? It has to do this if it's positive.
I just always know if it's positive or negative if I have the leading coefficient. So I guess I don't really know what to do.
So x squared has a positive leading coefficient. It looks like this. Since it's degree even, it has already 3 turns. It cannot turn again. So it must be a negative leading coefficient. Because it already has 3 turns. And we said for degree 4. If we turn the sides again to go up, then it's not going to be 3 turns. It's going to be 5 turns.
So if there is an odd amount of turns, it is
You
going
add
to be
1.
even?
You add 1. Yes.
I mean,
Whatever it is, you add 1.
this is different.
So since already we have 3 turns and we said degree 4, if I wanted to show it with a positive leading coefficient, it would have 2 more extra turns. Is that clear? So it has to be this way, because it already has 3 turns. You cannot have more.
Then I can have 1 more.
But then it's not degree 4.
Oh, okay.
So if we establish that it has 3 turns, and we establish that it has degree 4, it already has the turns done, so it cannot turn again.
Okay.
So the leading coefficient must be, one more time, negative. Use the graph to estimate the woman's minimum heart rate during the first 12 minutes. No, we have to look at the graph. This is the last question. Estimate the woman's minimum heart rate during the first 12 minutes using the graph. When was it? When was it? It was at 8 minutes, and how much is it roughly? 64, 65, perfect. And how many minutes, what about the maximum? Exactly 10 minutes, how much would it be? 150. So this is a typical example in which a polynomial function of degree 4 will be used to model